how to select maybe solids, hypothetical solids, and all of that. So that's how you add water. Now I'll select the property package. It will probably be wise here that I can say maybe using Payne Robinson. So here the fluid package, I'll click on add. This opens, then I'll scroll down and select Payne Robinson. Once you select everything, here is okay. Even the binary coefficients, step test, it just automatically calculates it. You don't need to change anything. So you have selected your Payne Robinson. You see that this shows okay. And when I look at this here, initially it was showing it had a red tick, but now it has blue. It's all blue. It shows that it's okay. Then I'll move to the simulation environment. Now this is where you build the simulation, but you need to understand what you're looking for. You need to understand the process before you start building the simulation, which is a mistake people do. They just get into the software, they are building a simulation without properly breaking down the problem. Now here you have the home tab, you have the economics where you calculate money and all of that, dynamics where you control your simulator, plans data, but we are not connected to any SCADA system, so this is not necessary for us. Equation oriented, when you start simulating, you will see what this is all for. Customize how the page looks like, resources, the flow sheet. Here you can control your flow sheet and what you'll be seeing. Here I've just selected temperature and pressure. All right. So we have a process here. Now when you look at this, we see the pressure, which is 43.7 psi that came in. But now look at the pressure. The pressure has increased drastically, and when you look at the temperature too, the temperature has also increased, and the molar flow is constant. You see, so we have successfully increased the pressure. So we have answered we have solved the engineering problem. Remember, at the end of the day, you want to solve your problem. The problem did not mention at the constant temperature, nor did it say anything. The problem was focused on increasing the pressure, which we have successfully increased the pressure. So this is a complete system on its own. And now we'll be looking at the more heavier, maybe if they said increase the pressure. From the view here, I'll open my model palette. Maybe they say we should increase the temperature. What do I need to increase the temperature? I need a heater, so I'll bring in a heater, and here the inlet now will be that high pressure water, and I'll also bring an outlet. The outlet is 1, which is empty, right? Energy. Remember, when a heater needs energy in order to work, so I'll bring in the energy stream, the energy unknown, delta P. Now I'll come to parameter and I'll look for this delta P. Delta P is just a change in the pressure, or yes, the change in pressure entering versus minus the change. Delta P is just change in pressure, which is pressure at the exit minus pressure at the entry. Maybe I want it to just be maybe around 10 psi, but I need to select the duty, maybe 10 BTU per hour. But now let us check. You see the temperature has slightly, or has not even increased. What do I need to do? I need to increase the duty. You see the way the temperature is increasing from 175 to 176. I increase it maybe to 1000 or to 10,000, 100,000. The temperature increases. Now, in order to check my stream, I'll readjust this way, bring this here. Now, look at the composition here, or the properties. Look at the water. It came in aqueous phase, that's liquid, and this is all that was entering. This is all the information automatically calculated for you. This is all that was entering. Look at the weight, the molar density, the mass density, and everything here. All the water was in the aqueous phase, temperature, pressure, everything. Now, high pressure, the temperature is the same, but what has happened? Pressure has increased. We're already at 4,424 bars, which is not ideal, but it's just an example. Look at the heater. When we included the heater, what came out of the heater? Look at the temperature. It has increased drastically to 139 degrees Celsius. And look at the pressure. It's still constant, right? Or it has even increased a bit. Yes, it has. No, it's still constant. The pressure has increased. So when you're running a simulation, you always have to be checking. And now you're running a simulation based on the desired output. So thank you for watching, and see you in the next video. We'll take each component and we'll break it down. We'll be solving some problems as we move on. Thank you.